Okay, hello guys. So this is A2 chemistry, the last part of our electrochemistry chapter. There's the series of 3 lectures. Lecture 1 and lecture 2 has already been uploaded. So this is the last part, that is the lecture 3. Okay. So let's begin. So first of all, electrolysis. So what is the meaning of electrolysis? Some basics are given here. I would first of all suggest you to pause this video and go through this slide. Okay, and go through this slide. Take some time, pause this video. Welcome back. Okay, so you know that during electrolysis what happens is that a charged substance or an ion, any ion which may be positive or which may be negative, any ion gets neutralized. That means during electrolysis an ion has to get neutral, or an ion has to be converted to a neutral form. Okay, so what happens is that you if you do notice that there is a red colored cat in the corner in one corner of the slide. Red cat, so red means reduction, which is the gain of electron, and cat stands for cation. Okay, so cations are reduced. Okay, so when two or more cations are present, the one which is easier to reduce will be reduced or will be neutralized. Okay, so anion, since red cat, so reduction of cations, so it must be oxidation of the anions, isn't it? So it's red. Let me increase the brightness. Okay, so it's the red cat, so reduction of cations, so it should be the oxidation of anions, and oxidation means loss of electrons. Okay, so look here, we all through our chapter, while we are talking about electrode potentials, we were focused, or we were asked to focus on reduction, isn't it? So now in case of anions, the anions will be oxidized. So still here we will focus on the reduction. When more than one anions are present, just look at their electrode potential values, that which anion is the hardest to reduce. So the anion which is the hardest to reduce must be the easiest to oxidize. Okay, so that's the thing. So for cations we will focus on reduction. So the ion which is easiest, so the cation which is easiest to reduce will be neutralized, and in case of anions we focus on oxidation, and oxidation is the opposite of reduction. So the anion which is hardest to oxidize, sorry, the anion which is hardest to reduce will be the easiest to oxidize, and hence will get reduced. Okay, now let's look at some more terms, like what is an anion. Okay, should I get some empty space? Okay, so tell me, oops, sorry, so tell me the meaning of an anion. Anion means a negative ion. Okay, how will you remember that? Look, a negative ion. So anion means a negative ion. And so what will be about cation? Cation, okay, So you will remember cation like this, that you will forget the Ca, okay. You are forgetting Ca, so what you are left with is the T ion, and T looks like plus, so it's the plus ion, means the positive ion, okay. So anion means a negative ion, and anion goes to anode. Anion is attracted to anode. So if anion is a negative ion, then anode is positive, okay. And if cation is a positive ion and cation goes to cathode, so cathode must be negative, okay. And now the red cat. So reduction of cation occurs where? At the cathode. So simple. So reduction of cation occurs at the cathode, and anions are oxidized. So oxidation of anions occur where? Obviously at the anode, okay, because anion goes to anode, okay. So that's the simple revision from our O-level syllabus. Now let's see, for example, so if anion is a negative ion, then anode is a positive electrode and cathode is a negative electrode. So anions are oxidized, that means anode is the electrode where oxidation occurs, and cathode is the electrode where reduction occurs, okay. So anode is the electrode where oxidation occurs, and cathode is the electrode where reduction occurs. Again red cat. So cations, so reduction of cations, red cat. Reduction occurs at cathode, red cat, okay. And cathode, cat ion is positive ion, so cathode is negative, okay. So let me tell you that I will perform the electrolysis of, say, for example, a solution of copper sulfate. No. Okay, one more thing before going into the details. Some anions like sulfate, nitrate, carbonate, etc., they are never discharged or neutralized during electrolysis. Now why is that? Look, let's see. Okay, so negative ions, the anions, so anions must be oxidized to become neutral, okay. And for oxidation, the anion has to travel at the anode, which is the positive electrode, okay. And so anode is the electrode where oxidation occurs, the positive electrode, and cathode is the electrode where reduction occurs, and cathode, the cation is positive, so cathode is negative, okay. So let me draw an anode over here, and let me draw a cathode over here. So in anode, so in the anode, oxidation of an ion occurs, and in the cathode, and in the cathode, reduction of an ion occurs, okay. Now you look at nitrate. Look here, we have got nitrate, and here is a neutral form of the reaction, NO2 and H2O, but here is no neutral form, so we won't take this, we will try to take this, okay. Now look, so NO3 will be converted to NO2, and you know that in the electrode potential equation, the left side contains the oxidized form and the right side contains the reduced form. So when you are going from left to right, that means you are doing reduction, and when you are going from right to left, that means you are doing oxidation. All right. Okay. Now, so if you want to make nitrate, so if you want to make nitrate neutral, then you have to go from left to right. That means you have to carry out reduction. Now tell me, at which electrode does reduction occurs? Yes, again, reduction occurs at the cathode, which is the negative electrode. So nitrate has to get reduced to become neutral, and for reduction nitrate has to go to cathode. Now tell me, will actually nitrate travel to the cathode? Yes. Actually no, because cathode is the cathode has got negative charge, and at the same time nitrate has also got negative charge, isn't it? So cathode has got negative charge and nitrate has got negative charge, so they would repel, and thus nitrate will never be neutralized. Okay. Okay, now tell me about sulfate. Look, so I am drawing an anode here. Anode is the positive electrode where oxidation occurs, and cathode is the negative electrode where reduction occurs. Okay, so now let's look at sulfate. So sulfate SO4 2 minus, and here is SO2. So if you want to neutralize sulfate, then you have to go again from the left side to the right side. So, and from left to right in the electrode potential, it is the reduction. Okay. So to neutralize the sulfate ion, you have to reduce the sulfate ion. Now in which electrode does reduction occurs? Reduction occurs at the cathode, which is negative. So for reduction to occur, the sulfate has to travel to the cathode. But will sulfate travel to cathode? The answer is no, because sulfate and cathode, both of them has got a negative charge, and sulfate is an anion, so it will travel to anode, but at the anode oxidation occurs, but sulfate needs reduction. So it will go to anode, but nothing will happen, because sulfate says that, oh, I need reduction, but you are trying to oxidize me. So then sulfate will try to travel to cathode for getting reduced, but the cathode will repel sulfate because of similar charge. Okay, so that's why during electrolysis sulfates, nitrates, and many other ions are not neutralized. Okay, what about hydroxide? Do you think it will get neutralized? Let's see. Let's find hydroxide and a neutral form. Okay, so here I have got hydroxide with some neutral substance in the opposite side of the equation. Okay, look, so here to here it is reduction, and here to here it is oxidation. So to convert hydroxide into neutral products, we must oxidize the hydroxide. Okay, now tell me where oxidation occurs. Oxidation obviously occurs at the anode, and anode is positive. So hydroxide will easily go to the anode, because anode is positive, hydroxide is negative. So hydroxide is going to get neutralized during the electrolysis. Okay. Now let's carry out the electrolysis of, for example, I am saying potassium in the mixture of potassium chloride and sodium fluoride. Okay, so this we have to make it neutral. Okay, So in potassium we have K plus and Cl minus and Na plus and F minus. Okay, so these are the plus ion, which means these are the cations. So our cations are K plus and Na plus, and anions are Cl minus and F minus. Okay, so let's mark the equations. Sorry. Let's mark the equations. So here is potassium, here is fluorine. No, okay. Here, oops. Here is fluorine. Then is there no sodium? Is there no chlorine? Oh yes, there is chlorine. Okay, although if sodium is not given, then I'm telling you Na plus plus E minus, this will give Na, and the electrode potential value is minus 2.71. Okay. Okay. Now let's see. The anions are chloride and fluoride. You know, anion means a negative ion. So chloride and fluorides are anions. Okay, so anions has to be oxidized. So let's find out which anion is very difficult to reduce, and that anion must be easier to oxidize. Okay, so the electrode potential value of chlorine is 1.36 and electrode potential value of fluoride is plus 2.87. So fluoride has got a higher electrode potential value than chlorine. So fluoride is easier to reduce and chloride is harder to reduce. So in comparison, what would happen is chloride will, since it is harder to reduce, that means it is easier to oxidize. So here chloride will get oxidized and form chlorine, and fluorine will remain unchanged. Okay. So in the electrolysis of sodium fluoride and potassium chloride, the chloride ion will get neutral. Okay. Now talking about the cation. The cation means C-A-T, T positive. So cation means positive ion, and again red cat. So cations has to get reduced. Okay, now let's see the electrode potential values of the cations, that means the positive ions. So potassium has the value minus 2.92 and sodium has the value minus 2.71. Okay, so these ions, one of them has to get reduced. Now tell me which has a higher electrode potential value. Compare the potassium and sodium. So sodium has got a mathematically higher electrode potential value, isn't it? So here in this case sodium will get sodium has got a higher electrode potential value, so it's easier to reduce the sodium, so sodium will be reduced, isn't it? Okay, so between potassium and sodium, sodium will get reduced and hence will turn into neutral form. All right. Okay, that's all for electrolysis. No, there is one more thing left, the concentration factor. Okay, I would ask you to focus on the values of chlorine and, it's difficult to say, right? Not yet. Okay, here I am asking you to focus on the values of chloride and hydroxide. Okay, so chloride is plus 1.36 and hydroxide is plus 0.40. So in normal state, tell me, these are all negative ions, isn't it? So negative ions means anions, so they has to get oxidized. So find the ion which is very hard to reduce. The ion which is very hard to, or or harder to reduce is easier to oxidize. So among by observing the values of chlorine and hydroxide, it is clear that hydroxide has a lower electrode potential value. So it's harder to reduce hydroxide. That means it is easier to oxidize the hydroxide. So in general, if you if you have a solution containing chloride and hydroxide, then hydroxide will get neutral. Okay, hydroxide will be oxidized and get neutral. But for a time being, just think that you are using a very much concentrated solution of sodium chloride that contains a lot of chloride ions. So what would happen? Let me write the equation. Okay, so if you increase the amount of chloride ions, then what would happen is that the equilibrium would shift to the left, isn't it? Equilibrium would shift to the left, and you know, from left to right is reduction and right to left is oxidation. So when if equilibrium is shifting to the left, that means more oxidation is occurring, that means less reduction is occurring. That means the value 1.36 will now be reduced because less reduction is occurring, and this value 1.36 will start to decrease because less reduction is occurring. So this value will start to decrease, and even this value on decreasing will become 0.1, that means even less than 0.4. Okay, that means very small amount of reduction is of chloride is occurring because the equilibrium now mostly lies to the left because of the very high concentration of chloride. So the electrode potential value has reduced because less reduction is occurring, and the value is reduced, and even it has become less than that of the value of the hydroxide ions. Okay, so now in the concentrated solution, now compare the values. Now which ion, is it the hydroxide or the chloride, is harder to reduce? Obviously, in comparison, the chloride ion now is harder to reduce. Okay, because its electrode potential value is now less. So it's harder to reduce, that means it's easier to oxidize. All right. So in the concentrated solution of sodium chloride, the chloride ion will get reduced. Okay. Okay, so that's all for electrolysis, the qualitative discussion of electrolysis. Now we will go for the quantitative discussion of electrolysis. Okay, so in the quantitative discussion, here we are going to find that during electrolysis how much product we are going to get. Okay, so how much product we are going to get. So just follow some steps, like first find the current. You will be provided with a current value or a charge value. So find the charge value from the current. You know the equation, Q is equal to IT, isn't it? I must be in ampere and T must be in seconds. Okay, so Q is equal to IT. From here you will get the charge, and the unit of charge is coulomb. Okay, and after finding the charge, then find the number of moles of electrons using this equation. That number of moles of electrons is equal to charge divided by F, where F is the Faraday constant. Now what's up to the Faraday constant we will discuss just after this content. Okay, so and F has the value of 96500 coulomb. Okay, So we can find the number of moles of electrons by dividing the charge with Faraday constant F, which is 96500. Next, using mole ratio, from the electron mole you find the mole number of the concerned substance, or you may prefer to use this shortcut, that mole of concerned substance is equal to mole of electrons divided by n, where n is the number of electrons in the electrode equation. Okay, n is the number of electrons in the electron equation. This n is the same as this n. Okay, here it's all there, or they both are the same. Okay, so but this shortcut for finding the number of moles of the concerned substance is only applicable if in the electrode equation the concerned substance is present in the amount as 1 mole. Okay, only then it is applicable, or else if it's not present in 1 mole, then you better apply the mole ratio of the electron to the substance to find the number of moles. Okay, let me give you one more formula, that number of moles of electrons by number of moles of substance from the raw data. Raw data means that either you have to find it or the data is given in the question. It will be equal to number of moles of electrons by number of moles of substance in the electrode equation. Okay, EQ means electrode equation. Okay, EQ. So you can also use this formula to find the number of moles of substance, and then from there, if you are asked to find the mass of the substance calculated, to find the mass of the substance which is collected at the anode or cathode, then just multiply the number of mole by the RMM to find the mass, or multiply by multiply the number of moles with the molar gas volume to find the moles. Okay, or whatever it is. Now let me show you an example of this. Let me show you an example. Okay, let me find a good space. Okay, I think this is good. Okay, write a question, please. Okay, I'm telling you that, okay, how much chlorine would be, hydrogen. Okay, how much hydrogen gas, that means you have to find both the mass and the volume. So how much hydrogen gas would be collected at the cathode? How much hydrogen would be collected at the cathode if a current of 10 ampere is passed for 100 seconds. All right, 10 ampere passed for 100 seconds. So how much hydrogen would be collected? Okay, let's see. So first find the charge. Q equals to IT. So I is 10, T is 100. So charge is 1000 coulomb. Okay, that's all right. Okay, now find the number of moles of electrons. So it should be the charge divided by 96500. Okay, so from here you will get to find the number of moles of electrons, which is 10 by 965. Okay, all right. Please copy up to this. Okay. Now, now let's look at the electrode equation of hydrogen. Okay. So 2H plus 2 electron minus, this would give you H2. So in the equation we have the number of moles of electrons as 2. We have the number of electrons, that means N will be equal to 2, and hydrogen, the concerned substance, has got 1 mole. Okay. So we can apply the shortcut. So number of mole of hydrogen will be equal to number of moles of electron found divided by number of moles, number of electrons in the equation. So it should be 10 by 965 divided by 2. Okay. So that is the number of moles of hydrogen. Please copy it. Okay. So mass, so if you are now asked to find the mass, so mass of hydrogen will be equal to the mole of hydrogen into the molecular mass of hydrogen, and volume, if I say that the molar gas volume is 24 dm cube, then volume of hydrogen equals to 10 by 965 divided by 2 into 24. Okay. So that's how it works. Okay. Now let me have some discussion about Faraday constant, or 1 Faraday. Okay. Actually, Faraday constant and 1 Faraday, they all means the same thing. So now what is a Faraday constant? Simply speaking, Faraday constant is the total charge of 1 mole electrons or 1 mole protons. Okay. So now tell me, what is the charge of 1 electron? It's 1.6 into 10 to the power, oops, so 1 electron has got a charge of 1.6 into 10 to the power minus 19 coulomb. Okay. Now tell me, how many electrons are there, or how many protons are there in 1 mole? So 1 mole is equal to, so 1 mole is equal to 6.02, there is no space. Okay. So charge of 1 electron is 1.6 into 10 to the power minus 19 coulomb, and in 1 mole we have 6.02 into 10 to the power 23 electrons or protons. So the charge of 1 mole electron will be the multiplied product of these two, isn't it? So that is the 1 Faraday. So 1 Faraday equals to charge of 1 electron. 1 Faraday equals to 1 mole, which is the Avogadro number, represented as L, and charge of 1 electron, which is represented as E. Okay. So 1 Faraday or Faraday constant equals to L into E. So you will get a value which is somewhat around 96500. You know that this value of 1 E or 1 mole, the Avogadro number sometimes varies, that somebody says 6.0 into 10 to the power 23, somebody says 6.02, somebody says 6.023. So this value can vary from one perspective to another perspective. So the internationally accepted value of 1 Faraday or the Faraday constant is 96500 coulomb. Okay, I hope you have got it. If you have any problem, please inform me in the comment section, or you can also add me or contact with me through WhatsApp, and my phone number is 01 okay plus 8801749339 okay. So this is my contact number through WhatsApp. You can send me your problems through WhatsApp, or you can tell me your problem in the comments section below. I will try to solve it. Okay. So thank you guys. That's all for today. Thanks a lot. Thank you very much.